guess I could take my mask off so I'm a little less muffled. Okay, lesson 2.5. First of all, some of the material that we covered in 2.4, where we were working to find our zeros. It was 2.4, wasn't it? Yeah. In 2.4, where we were working to find our zeros and whatnot. Okay, that's going to continue in 2.5. May not get to that till tomorrow, but we're still going to be working to find zeros. The difference is now instead of finding all real zeros, we'll be finding all zeros, period. So even zeros that are not real, which takes you a direction, a hint of where we're going today. Sorry, Maggie, I love the look on your face. Yep. Okay, imaginary numbers come back into your math world today. I'll review them. I'll go over what you don't need to know a ton about them, but we'll go over a little bit about them as we go through. So, first of all, review. You've already seen fundamental theorem of algebra. A polynomial function of degree n has n complex zeros, real and non-real. Some of these zeros may have a multiplicity greater than 1. In other words, they might be repeated. So, when we talk about fundamental theorem of algebra, we've talked in the past that a polynomial of degree n, we always say, can have at most n real zeros, right? Okay. There are times where it might be degree 4, but we only see 3 zeros or something like that. Okay. It doesn't mean the other zero is not there. It just means that it might be what we will call complex. If you remember, complex is a name for the numbers that involve the imaginary portion. Okay, so we're talking about real and non-real numbers. Linear factorization theorem. Given the function f of x of degree n, again, as long as n is greater than 0, then f of x has precisely n linear factors. Okay, that goes along with the fact that if it's degree n and it has n zeros, each of those zeros is represented by a factor. Now, those factors could represent rational, but also irrational and complex, or the non-real. And we're going to talk about that, where a is the leading coefficient, of course. Okay, this is a big one right here. How much we do with this may not happen until tomorrow. Might happen later today. Oh, it should happen later today. We should get that far. Complex conjugate zeros theorem. Given f of x with real coefficients. So that just means given a function that looks like a normal function. Okay? Real numbers in front of it. If a plus bi is a 0 of f of x, then so is its conjugate. You guys remember how conjugates work? Yeah, you flip that middle sign, right? So when we talk about the conjugate of a plus bi, it's taking the sign in front of the imaginary portion and changing that. So the conjugate of a plus bi is a minus bi. So if you have a root that involves an imaginary number, so in other words, if it is a complex root, there will be a conjugate root just like it. Okay? Keep that bit tucked in the back of your head because you'll have to know that later on. Now, before we continue, first of all, tell me, how is that pin showing up on the screen? Okay, well, it's a pink, but it's a darker pink. So I just know the brighter colors, you guys complain sometimes. So, okay, before I forget, let's talk about what we know about I. I'm just going to write it right in here. Because before we proceed, we kind of need to review I. What is I? Okay, so officially, by definition, I is the square root of negative 1. Okay, called the imaginary unit, right? Here's the other important thing to know. If I is the square root of negative 1, what is I squared? Negative 1. Because when you square a square root, you get what's under the radical. So I squared is negative 1. Okay, you got it? Okay, let's look at some various types of problems. Write the polynomial function in standard form. Identify the zeros of the function and the x-intercepts of the graph. So if you caught it, we've got three things to do here, yes? Standard form, zeros, x-intercepts. Okay, what do you guys remember about standard form? Or what do you know? How do we get this? Okay, descending order of degrees, which means what do I have to do to get there? FOIL it out, multiply it out. Okay, so in other words, right now we're in factored form, which factored form has a lot of value for us and tells us a lot about it, but we also need to be able to talk standard form. So in this case, x minus 2i times x plus 2i, you are FOILing. Or multiplying, I should say, but yes, FOILing. X times x, x squared. And then I like to do outsides. X times 2i.
2xi.
He says 2xi. I'm going to say 2ix. It's the same thing. Okay, it's just which one do you more normally see? And it's more the more normal one is 2ix. Does that make sense?
Well, which one's going to be more important, the x or the I?
Well, what it is your x is still your variable. Your I is still part of your coefficient. And so the variable still goes at the end. I is more the coefficient. I missed something over there. Okay. So x times x, x squared. X times 2i, 2ix. Minus 2i times x? Minus 2ix. And minus 2i times plus 2i. Minus 4i squared. Okay? It's not a good standard form, so let's clean it up. What do you notice?
Can't we just do x squared? And it doesn't cancel out because they have the same cancel.
Okay, so first of all, notice x minus 2i and x plus 2i were what we call conjugates. And when you multiply conjugates, those middle terms cancel.
It doesn't have the I squared.
So I'm going to have f of x equals x squared
Minus.
Plus 4?
What do you know about I squared?
It's going to be minus 1.
I squared is negative 1, and negative 4 times the negative 1 makes it a plus 4. So for standard form, I'm looking for f of x equals x squared plus 4.
I was thinking it's x squared equals 4.
No,
I was going to say x squared.
we're not solving this. It doesn't say equals 0. We're just putting it in standard form. Okay, so when you put something in standard form, you're not going to have i's in standard form. If you end up with an I, then you made a mistake, go back and look for a fix. But always remember that I squared is negative 1. And so it changes it, drop it out and change the sign of the number. Okay, zeros. It wants us to identify the zeros of the function. How do I find zeros of a function? We're not graphing it. Set what equal to 0?
X squared plus 4.
Okay, you could set x squared plus 4 equal to 0. Could we go back and set the initial equation, or in other words, those factors equal to 0? I mean, you could do x squared plus 4 equals 0. In this case, it would work. However, standard form will always work. The factored form is better. So in order to find zeros, you want to set each factor equal to 0, because zeros are solutions to this equation. Okay? So, let's see. What do we have? X minus 2i equals 0. X plus 2i equals 0. So what do we find out? X equals
Negative 2i, or 2i, negative 2i.
Yep. Positive 2i and negative 2i. And what are these?
Are zeros.
Your zeros.
So it's okay if we have i's in our zeros?
Yep. Okay, because zeros are solutions to the equation. And most often we just look for the real solutions. But today we're looking for any solution. So real or non-real. In this case, my solutions are imaginary. Okay, one last thing, and that is the x-intercepts. What are we often taught about x-intercepts? And how they connect to zeros. They're the same, yes? And they are the same in a solution when we're just talking about the real zeros. Okay? If you graph this, can you see a 0 of 2i and a 0 of negative 2i? No. Okay? You don't see 2i and negative 2i on your graph. Okay? So, if my only zeros are imaginary, what would you guess about x-intercepts? There are none. Now, if you want to graph this on your calculator, what would you graph on your calculator? The standard form, right? Because sorry guys, you can't graph x minus 2i times x plus 2i. You can't graph that. Okay, your calculator won't, at least to my knowledge. Someone may prove me wrong one of these days, but you can't graph with i's. However, the standard form, the i's are missing. Well, what do you see about the graph f of x equals x squared plus 4?
It wouldn't be on the x-intercept because the parabola would be up 4.
Yeah, x squared plus 4 is a parabola moved up 4. And if it's a parabola moved up 4, is it ever going to cross the x-axis? No. So thus, we have no x-intercepts. And my reasoning for no x-intercepts? I'm going to say because my zeros are imaginary. So notice you could graph this one on the calculator, but you can also just go by looking at your zeros. So just kind of be aware, I think it was Levi that when we first started talking about finding zeros, he said graph it, which that works as long as we're only finding real zeros. But in this case, today we're looking for all zeros, and so in that case, we needed to look at the factors. Questions on that one? Okay, shall we try B then? F of x equals x minus 3 times x minus 3 times x minus square root of 2i times x plus square root of 2i. Note in this case, it's x minus 3 repeats, right? So remember how we talked multiplicities? Okay, the fact that there are two x minus 3's means it has a multiplicity of 2. Okay, so this one, when we multiply it out, it's going to be x to the 4th. So officially, you should have 4 zeros when it's x to the 4th, yes? But a multiplicity of 2 takes the spot of 2 zeros, so to speak. Okay, does that make sense? And so you will still only see 3, but it's because there's that multiplicity that's more than 1. Okay, guys, what's the first thing we have to do here? Standard form. So what do we have to do to get to standard form? Okay, distribute, FOIL. We have how many sets of parentheses? 4. So that means you want to do sets of 2, right? And then worry about the answer. Now, you always want to multiply. When you have conjugates that involve your imaginary numbers, that involve your i's, you always want to multiply those together first. Meaning, these two, the x minus radical 2i and x plus radical 2i, make sure that is a pair you multiply together. Don't try and say, oh, I'm going to multiply x minus 3 and x minus radical 2i. That's going to make life a lot messier. Okay, so anytime you have a conjugate pair, make sure that they get multiplied together. So, now, what does that mean about x minus 3 and x minus 3? If I'm multiplying these two together, then x minus 3 times x minus 3 can be multiplied together. Okay, x minus 3 times x minus 3, x times x, x squared, x times minus 3, minus 3x, negative 3 times x, negative 3x. So what are my outsides and insides together? Negative 6x. And then last, negative 3 times negative 3, plus 9. Okay, so those are my first two FOILed together. Now, let's look at the next two. X times x is x squared. Okay, what about my outsides? Go ahead and say it. They cancel. Okay, yeah, go ahead and, yep, let's get that out there. The fact that when we look at the outsides, x times radical 2i is going to be a positive radical 2i times x, right? But then what are my insides? Negative radical 2i times x. So what happens when you have a positive radical 2ix and a negative radical 2ix? They cancel. They're conjugates, folks. Those middle terms cancel. Do I need to write those out? I don't. If you prefer to, then go for it, but they're going to cancel. So that just takes me to doing my last. Negative radical 2i times positive radical 2i.
You're saying that x times square root of 2i cancels?
It's going to cancel because then you have to do x times negative radical 2i.
Oh,
your outsides and insides will cancel.
You skipped 2 steps then?
I did them. I just didn't write them down.
Yeah. That's what
I mean, when my opinion is, you guys are at pre-cal level. If you're foiling something, like right here, did I write out minus 3x minus 3x? I went to minus 6x. I went ahead and put those like terms together. Same thing that I'm going to do here, except that they cancel. Okay? So, real quick side note. Negative radical 2i times positive radical 2i. Did anyone figure that out? I don't know if I heard it out there or not. I heard lots of things. I didn't hear anything right, but it could have been out there. But we wouldn't leave it as negative 2i squared. Plus 2. Okay, because, so let's go through the step real quick. Negative times positive is going to be a negative. Radical 2 times radical 2. 2. When you multiply something by itself under the radical, they drop off. I times I squared. So you start off with minus 2i squared. But I squared is negative 1. And negative 1 times negative 2 means this is going to be a plus 2. So how do you feel if I say that when we FOIL those two together, it becomes x squared plus 2? And what do you notice? All of our i's canceled out, disappeared. And that's what should happen when you multiply conjugates that involve i's. Your i's should disappear. I was waiting for that. I really was.
I thought the same thing.
Okay, now what? Got to multiply again? Big old distributive property, right? How do you guys want to do this? Nope, we're doing it. I know how I like to do it, but it's not. I tend to like, when there's two parentheses, I tend to like to take each thing in the two parentheses and multiply it by each of the three items. Some of you guys may do it the other way around. Yeah, kind of. Like I tend to go, okay, x squared times everything in this parenthesis. And then 2 times everything in this parenthesis. It's just how my brain works. I don't know. Now, what's the other option? X squared here times both of these two, minus 6x times both of these two, and positive 9 times both of these two. Does it matter? Doesn't matter one bit. It all works out the same in the end. Okay? So, if I take my x squared from the second and multiply by each of these three, x squared times x squared, x to the fourth. X squared times minus 6x. Minus 6x cubed. And x squared times 9 plus 9x squared. And now I do the same thing with the 2. 2 times everything in the trinomial. So 2 times x squared, 2x squared. 2 times minus 6x, minus 12x. 2 times 9, 18. Okay, final cleanup step. Yep, combine like terms. X to the fourth is good. Crud. I hope I said it right. I don't know if I have something wrong up here. Did I say x squared?
No, you just did it.
I just wrote it?
Yeah.
Okay, good.
How did you say x? When I saw you wrote x squared, and then I got really confused by the
Okay, so x to the fourth minus 6x cubed carries down. 9x squared plus 2x squared is plus 11x squared minus 12x plus 18. Okay, guys, the downfall of this lesson, you have lots of multiplying like this to do. Okay? I mean, it's good. It's algebra. It's just tedious. Okay? So, this is my standard form. Now, one thing I will say, okay, I kind of caught my mistake because as I'm looking at this, I had 3x squared terms. And my brain knew enough to know that it didn't seem right that I had 3x squared terms. And if you even start looking at it, I had no x to the first term. So that's how I could kind of like, wait a minute, I did something wrong. So always kind of double check yourself if you feel like you have a lot of the same power and not enough of others. Zeros. You got some zeros for me?
3 plus or minus or minus.
Okay, so zeros, we're just taking each of the original factors and setting them equal to 0, right? So officially I'm going to have x minus 3 equals 0. X minus 3 equals 0 if you want. X minus radical 2i equals 0. And x plus radical 2i equals 0. So you solve each of those. Now notice, I just did it for fun, but I put x minus 3 equal to 0 twice. Did I really need to do that? No. How many times do I need to give 3 as an answer? Just once. We're just talking zeros. So my zeros are 3, and then you could say radical 2i and negative radical 2i, or you could say plus or minus radical 2 times I. It is definitely okay to be using the plus or minus in this lesson. We'll use it a lot. And lastly, yes, I'm listening.
Okay.
Technically, it's been outside of the radical the whole time. May or may not have looked like it, and when I say it, it's kind of hard to differentiate. So the virtual question right now was on the, okay, so I'll get to intercepts here in a moment, but the virtual question here on the moment is that I, officially, if you look back at the original problem, that I is not underneath the radical. Okay? When I say it, I say radical 2i. That could go either way if you think about it. That's the radical of 2i or the radical of 2 times I. I don't bother to take the time to differentiate because I just don't. but realize that that I is not under the radical there. Okay, so that is something to be careful about. Okay, were you guys having x-intercepts discussion? What x-intercepts do I have?
We'll have real ones, which is
3. Anything else?
I don't think so. Because
No.
I pick on
Okay. Plus and minus the radical 2 times I. Those are imaginary. They're not going to physically show up. So x-intercepts, my only x-intercept is
3.
x equals 3. Do you need to graph that?
You can.
You can, but do you have to get that answer? No. You just have to look at your list of zeros and decipher, oh, okay, those are imaginary. They're not going to count as x-intercepts. Okay. Questions there? Okay. I am hopeful. I don't know if I can get through example 2 and 3, but let's at least make it through 2. Example 2, asking us to write a polynomial function of minimum degree in standard form with real coefficients whose zeros include -3, 4, and 2 minus I. Standard form, and we're provided the zeros of -3, 4, and 2 minus I. If you think about this, you've done this before. In fact, you technically did this on the quiz. Okay? We take those zeros and we put them into the factors, and then we can multiply to get to standard form. Yes? That's the basic gist of it. Now, be thinking, because there's a twist, because we're in the next lesson. There's a slight twist. Now, okay, so f of x, first of all, -3 is a 0. How do I express that as a factor?
X plus 3.
X plus 3. Good. 4, how do I express that 0 as a factor?
X minus 4.
Okay. X minus 4. Thoughts on this 2 minus I?
Yeah. Okay, so. Would it have to be like 2x? Well, no. Because this is the complete conjugate zeros theorem when it's you reverse the sign, so.
Whoa, hold that thought.
No?
Yes and no. You're not taking that the right way. I mean, we are going to need to talk about the complex conjugate zeros theorem. I'm glad you bring that up because that is a necessity here. However, we still have to use the given 2 minus I. Ashley, what were you going to say? Okay, so you guys are getting the basics. Okay, so I'm going to write this out kind of initially. You will probably skip this step as you get better, but officially, it's always we're doing what? X minus the given value, right? So when it was -3, we did x minus -3, but you guys shortcut that to x plus 3. You just do the opposite sign, right? When it was 4, you did x minus the value. So we're going to do x minus the quantity 2 minus I. So x minus the quantity 2 minus I. Now, I'll be honest. I'm writing this out with 2 sets of parentheses right now just to kind of get everyone in the ballpark, okay? Eventually, I won't write that. But the idea of it's x minus the quantity 2 minus I. When you go to simplify that and get it so we just have 1 set of parentheses, it's going to be what? X minus 2 plus I. That's what I was trying to get you to say there. Now, I'm going to write it in a second line. You may not want to, you may quickly get out of the habit of writing that initial row with the extra parentheses in there. but like that's the visual to help you see it. Okay? Now, I have 3 zeros. It didn't tell me how many zeros I have to use here, did it? It just said of minimum degree. They gave me 3, I've used 3. Levi brought up complex conjugate zeros theorem. What's that tell me here? Given function f of x with real coefficients, if a plus bi is a 0, then so is its conjugate, a minus bi. So, what am I saying here? If 2 minus I is a 0?
2 plus I.
Yep. So is its conjugate, which is 2 plus I. So that means I'm going to have a 4th set of parentheses, correct? This time, it's going to be x minus the quantity 2 plus I. And if I clean that out, clean that up, without those inner parentheses, it really becomes x
Plus 2 minus I?
minus 2 minus I.
Okay. That's what I wrote down. Okay. So when we put the x, when we do like that x minus our integer, is it always going to be like a minus thing?
It's yes.
Okay.
Yep, by rule, it's always x minus whatever the 0 is. So when your 0 is something like 2 minus I or 2 plus I, just remember you're changing both signs. That's the key there. Now, what makes this problem difficult? We have to multiply all of them out. Okay? So notice, yes, it is important that you get rid of these inside parentheses here so that you don't have to figure that all out. But we are still multiplying out. What did I say earlier when multiplying? Okay, make sure you do those conjugates together. So in this case, that means my x plus 3 and x minus 4 can be multiplied together. And then those i's can be multiplied together. I'll be honest, it looks horrible. It will simplify somewhat, though. Okay? I mean, I told you guys, this is the concept behind it is not the difficult part. It's this. Okay, let's not make careless mistakes. It's tedious. I'm being upfront here. Okay, so let's get this one out of the way. X plus 3 times x minus 4. FOIL it. X times x. X squared. Minus 4x. Plus 3x, which makes it minus x. And then 3 times minus 4. Minus 12. Okay. We've got to be organized here. As I go about this, I'm going to take my first x in my first parenthesis and multiply it by each of the 3 items in the last parenthesis. Sound good? So x times x, x squared. X times minus 2, minus 2x. And x times minus I, minus ix. Now I'm going to take my negative 2 in the middle, and I'm going to multiply it by everything in the last parenthesis. Negative 2 times x, negative 2x, negative 2 times negative 2, plus 4, negative 2 times negative I, plus 2i. And then I times everything in the last parenthesis. I times x plus ix. I times negative 2, negative 2i. I times negative I. Nope. You're multiplying. I times negative I, negative I squared. Okay. So, clean up. What do you see? A lot of things. Do some of those things cancel?
Yeah.
Yes. Okay. Minus ix cancels with plus ix. That's nice. Plus 2i cancels with minus I. And what do you know about minus I squared? It's the same thing as saying positive 1, correct? So, Jace made the comment, all the i's cancel. All our regular i's cancel, and our I squared can become a plus 1. Well, yeah. I squared is negative 1 minus I squared minus negative 1. Okay, so let me carry down my first parenthesis still of x squared minus x minus 12. Okay, yep, now we're going to combine like terms. So we have x squared minus 2x minus 2x is minus 4x plus 4, and now a plus 1 does make it plus 5. It's a trinomial, but at least all the i's disappeared. And here's the deal, guys. If you multiply conjugates and your i's don't disappear, you've made a mistake. And I'm down to a minute of class. Okay, realizing what has to happen to finish this off. Okay, you're going to have to multiply trinomial times trinomial. Trinomial, you're going to have to, like, distribute all that. Yep. Okay. So, as Jace pointed out, you're going to have 9 terms that they will then simplify down. Okay. Now, your homework for tonight, finish that problem. And if you're someone that you write and put in your notes and you don't want to dare go wrong, then write it on a scrap of paper, you know. So tomorrow when you come into class, that's what we're going to start with, is making sure everyone ends up in the right place. Okay? I had hoped to finish that, but thank you. You too, Shelby.